Today we're going to talk about parameter changes of linear equations. And I'm going to be honest with you, when we do this lesson today, this is probably one of the hardest lessons of the year. Maybe not what I'm going to do today, but definitely what I'm going to do on Thursday. It's probably one of the hardest lessons of the year to understand well, okay? When this TEAC, when they first released that they were going to start having us teach this to you guys, I really struggled with how do I teach this to my students. I talked to a lot of people about it, right? High school teachers, I asked them about it. I talked to college professors, but I was trying to wrap my head around it to make sense of it, because it was something that I had never even looked at before. I didn't even know it existed. So that was where I had to start with this, was even, wrapping my head around it. But I think over the last probably 5 years, I've gotten pretty good at it. And I think I've gotten it to the point now where I can teach it pretty well. But what parameter changes let's just first understand what that means. What a parameter change is we're going to take functions, and we're only going to deal with linear equations again. So we're going to go all the way back to something like this, right? Like something like this, like f of x equals x plus 1, right? And what we're going to do is we're going to do different things to f of x. We're going to do like something like f of x plus 1. What does that do to the graph? And we're going to do something like this, like f of x plus 1, like that. These two things do different things to the graph, okay? And that's what we're going to talk about today. You can actually test these on a calculator, right? So if I graph f of x plus 1, there it is, right? And watch what I can do. I've never shown you this before, but you can say graph f1, and that's what we had from a minute ago. Look how it's bold. Everybody see how it's bold, right? How it's darker? Yes, no?
Yep.
All right, you can do f1 of x, right? So the first function, x, plus 1, and so you can even just see what it looks like. All right, so what does that look like it did? How did the blue light
moved the graph up by 1?
That's exactly it. It just translated the graph up 1, right? And that's what this is going to do. It's just going to translate the graph up 1. But we're going to talk much deeper about it, all right? What we're going to do is we're going to talk about two big things. What happens to the xy coordinates of that graph, all right? So I guess I should make the table like I would do. So I'm going to break this down step by step. It's important to always keep the table up of f of x. I'm going to put these together side by side. So I have f of x equals x plus 1, all right? And I'm going to make its table. So let's do some answers. -1, 0, negative, let's do -2, -1, 0, 1, and 2, all right? All right. So let's just look at these points. When you put a -2 in the machine, you get out a -1. When you put a -1 in, you get out a 0. When you put a 0 in, you get a 1. You get a 2. You get a 3, right? All right, now let's look at f of x plus 1, right? We already looked at the graph and we're like, it's translating the graph up 1. Yes, but it's even interesting is what's happening to the points, all right? Now, when you put a -2 into the machine, what it's going to do, all right, first things first, what's f of x another word for? F of x another word for what?
Y.
Why?
For y. So this is like y is getting 1 added to it, right? So if I wanted to look what the table looks like, if I know what this table looks like right here, then I can easily find out what this table looks like. And when I figured this out the first time, I was pretty blown away with it, not for necessarily this problem, but for some of the other ones. I can predict what the table is going to look like for this other graph because I know what's happening with f of x plus 1. So all I have to do is the y's are going to be adding 1. So if the x was -2, the y now is going to be we're going to add 1 to it, so it's going to be 0. -1 will be 1. 0 will be 2. 1 will be 3. 2 will be 4. All I'm doing, if you can look at what I'm doing here, all I'm doing is those points are just getting added 1, right, to make these points. And when I graph that, right, if I graph the original points, right, -2 is -1. -1 is 0.
Mr.
0 is
Gillespie,
1. Go ahead.
You cut out for me for a bit.
Okay, well. So that's what the f of x plus 1 looks like. F of x equals x plus 1 looks like. And if we look at these new points, look, -2 is 0. I'll do it in a different color. -2 is 0. -1 is 1. 0 is 2. 1 is 3. And you can see what's happening. What's mathematically happening, I want you to see this. What's mathematically happening is each of the points is moving up 1 on the y. Yeah? Does that make sense, guys? What's happening there?
Yeah.
Yes?
Yes, sir.
Yeah.
Okay. Now what's happening to the points, right? In this graph, we had x comma y. In this graph, we're going to have x comma y plus 1. That's how they're related to each other. If you know what that xy is, you know that xy is going to be x comma x plus y plus 1. All right. So that's the first one. So what does that do? So let's go back to the notes. So if I have f of x plus d, right, it's going to translate the y. You know, I don't even like the way I wrote this. It's going to translate the, let's change this to graph, d units up or down. Right? And the points are going to be x comma y plus whatever d is. All right. Questions so far? Before I move on, I want to make sure we understand that. Anyone? Okay, so if you see f of x plus d with the d outside the parentheses, it's just going to translate the graph up, right? So now let's look at the next one. Now this time, f2, we're going to do f of f2 of x is equal to x, and we're going to put the -3 inside the parentheses. That's different than putting it outside the parentheses. Now we just want to see, anybody, let me do this before I even press enter. Anybody want to make a prediction of what that's going to do without looking at the notes? Because the notes are actually wrong, just so you know. But what do you guys predict? What do you think that's going to do? We kind of talked about this before with quadratics.
It will
Move it sideways.
Okay, so Josh is right. It's going to translate it sideways, but is it going to translate it left or right?
Right.
Let's see. Oh, did I type something? I think I typed. Oh, yeah, I did. What did I do, guys? My daughter does this all the time. I put the negative sign instead of -3, right? And it says times, so you got to be careful. So x -3. There we go. All right. Now I got to take a picture of this. I can't take a picture of this. I forgot. All right. Look at what's happening here. Can you see my arrow? Yes? No?
Yes.
All right. It looks like from the blue line to the red line, because remember the blue line's my original, that I'm moving it down 3, but that's just an illusion of movement down 3. It's because linear equations, it's kind of hard to differentiate them sometimes. With quadratics, it's much easier, but with linears, it's kind of hard to see. But what's really happening from the blue line to the red line is I'm moving forward 1, 2, 3. You see it? It's actually translating the graph to the right 3 times. So how is that happening? I really struggled with this when I first learned it, okay? I couldn't really wrap my head around it that much. So I'm going to make this here, and I'm gonna get rid of this. Should just rewrote the whole thing. I'm gonna erase that much. All right, so that's still f of x, right? All right, so here's the next thing. Let's change all this up. All right, if it's happening, inside the parentheses. So I'm doing f of x plus 3. It's happening inside the parentheses. I know this is the rule that you need to follow. If it happens inside the parentheses, it's going to affect the x, not the y. That's the first thing. If it happens inside the parentheses of the f of x, it's going to affect the x and not the y. Here's the second thing. If I saw plus 3, I would think that it's going to move it. Oh, did I do? Yeah, look. Oh, I was doing f of x minus 3. No wonder. No, go away. Let me do this. All right, so I was doing f of x minus 3. All right. So my brain would look at this and say, ooh, and I did. I struggled with this when I first learned this. It says f of x minus 3. So I would think that it would move it left 3, but it's actually going to move it right 3. It's going to translate the graph right 3. In fact, what I first discovered was it's going to do the exact opposite inside a parenthesis. This is the part that's hard for some people, right? If I was getting ready for the EOC, I would spend a long time on this, making sure we caught this. If it happens inside the parentheses, it's opposite. What do I mean? Well, if it was like f of x minus 3, then it would actually translate the graph right 3, not left 3, yeah? If it was f of x plus 3, it would actually move it left 3. It would do the opposite of it. So I got a question for you. We're going to do this tomorrow or Thursday. But what do you think 2x would do? You think it would double the x? What do you think it would do? You might want to make a prediction.
Maybe stretch the graph.
It is going to stretch it. It will do something like that. But how is the question. What is the, so here's, I'll just give it to you because I was kind of blown away when I discovered this, right? For myself, other people already knew it. But what's the 2 doing to x? It's multiplying. So instead of multiplying by 2, it's going to divide by 2. So instead of doubling the number, it's going to take half of the number, right? So it actually does the opposite inside the parenthesis. So when you see stuff inside parentheses, you got to be careful. It says minus 3, but it's actually going to translate it right 3. Yeah? It's going to take each one of these points, and look at this. It's going to take each point, and it's going to move it 1, 2, 3 to the left, to the right, sorry. 1, 2, 3. So it's going to move this point here. It's going to move that point 1, 2, 3 here. It's going to move that point 1, 2, 3 here. And so the graph is going to look like this, and it's going to translate it forward 3 or horizontally 3. Yeah? Does that make sense?
Yes.
All right.
Yes.
Okay. So can I predict what the table's going to look like? I don't want to look at this. Don't even look at this. Can I predict what the table's going to look like? This is where I was blown away. Well, here's what I can do. I know that the y's are going to stay the same. Right? These are these. I know those aren't going to change. What I am going to change, though, is I'm going to plug these in for my x's, but I'm not going to subtract 3. I'm going to add 3 to them. So negative 2 becomes 1. Negative 1 becomes 2. 0 becomes 3. 1 becomes 4. And 2 becomes 5. And if I look at this graph over here, look at these points that I made, right? This point here. Let me change the color again. This point here, this point here, and this point here. I have these points on this new green table, right? What is this point? This is 1, negative 1, right here, right? This is 1, negative 1. There's that point. What is this? This is 2, 0. That's this point. You see it? They're all there. So without doing any work, I can predict what it's going to look like. All right. That's the 2 things we need to get in our heads, right? The 2 things we need to get is what happens when we do f of x plus something. So somebody summarize. What's going to happen when I do f of x plus something? What's it going to do?
going to translate the graph up or down.
It's going to translate. We're going to call that vertically from now on, okay? Vertical translations. Either up or down. That's correct. Now, what would f of x minus d do? Plus or minus. It would horizontally, that's right, horizontal translations. But I got to be careful. Horizontal translations actually affect them opposite of what they say. And the reason I have, anytime I sit around with like math gurus, right, the mathematicians at universities or whatever, I always bring this up with them, okay? They probably think I'm annoying. And I always ask them, how come the stuff that's happening inside the parentheses are happening opposite, right? And I never get a good answer. I have a feeling, my sneaky suspicion, and I'm not sure this is positively right, okay? But I have a suspicion that why that's true is that because we write things in terms of x and then y, right? We put numbers in for x and we get numbers out for y. Because of that's the way we do it, that's where the negative is happening from it, right? What this is saying is the x's, what this is saying here is the x's are going to appear like they're minus d smaller, yeah? So it has something to do because we write things in x, we put numbers in for x and we get them out for y. That's what's going on. I still don't have a great answer for it. In fact, if somebody wants to go research it and come up with a good reason, a good enough reason that it makes sense to us mathematically, there's definitely a lot of bonus points sitting around for somebody who can figure it out, okay? Or research it or whatever. All right, so plus d translates vertically. Plus or minus d inside of parentheses translates horizontally, right? The coordinates for f of x plus d with the d outside the parentheses is x comma y plus d. The coordinates for these points is going to be x plus d comma y. Remember, because this is going to be opposite. All right, so that's the key. And I don't think those are too bad. Let's fix this. Okay, I need you guys to look at this second piece here. You can tell when I made this that I really didn't understand what I was talking about. There's a big typo there. Can anybody find the big typo?
The C's supposed to be going to the right side, not to the left.
Yep. Okay, so let's fix this. This is f of x. This is f of x minus c, okay? Okay? And the arrow is actually going the wrong way because we know that minusing c would actually move the arrow this way. So it's a train wreck, and that's okay that it's a train wreck because I'd rather teach through it. And you guys can see that even I made mistakes with this. Right? It's just going to move the points forward, c amount. All right. So let's look at this. Here's what we're going to do. Today, we're only going to do this. We're going to find out what does f of x plus c do? What does f of x minus c do? That's all we're going to do today. We need to write these. I would recommend for you guys, if you have two pieces of paper, to maybe do them on. Today, we're just going to do those first two. We're not going to do what these do today, okay? What the second two do. We're not going to mess with those. We're going to mess with those next time. All right. So here we go. The first thing we need to do is we need to find the table of f of x because that table is going to help us with the rest. So let's just put in -2, -1, 0, 1, and 2. All right, so plug those in the machine. -2 times 2 is -4 plus 4 is 0. -1, that's -2 plus 4 is positive 2, right? Put a 0 in, 4. Put a 1 in, 6. And then 8. Right? All right, so let's graph these. -2, 0 is here. -1, 2 is here. 1, 6. 0, 4 is here. 1, 6 is here. 2, 8 is here. I'm going to try to draw this carefully. It's going to look like this. That's f of x, right? All right. Next thing. Now we're going to figure out what does f of x plus, we're doing this here, plus c is 2. So what would f of x plus 2 look like? All right, the first thing we're going to do it in 3 ways. We're going to say what happens to the coordinates, what happens to the table. Actually, we're going to do it 4 ways. What happens to the coordinates, what happens to the table, what happens to the graph, and then make a description of that graph. All right? So first thing, f of x plus 2. Somebody want to take a shot at what happens to the xy coordinates? Anybody?
They're gonna go to the left.
Okay, so let's talk our way through it. It's happening outside the parentheses, right? This is happening outside the parenthesis. When it happens outside the parenthesis, does it affect the x or the y?
The y.
The y. So I know that the x is going to stay the same. So it's going to be x comma. Now when it affects the y, it has to affect it vertically, right? So it's either going to move it up or down or something dealing with the vertical. So what do you guys think? It's actually going to take whatever the y was and add 2. So let's predict what the points are going to look like. Well, it says the x's stay the same, so just write the x's. Oops. What's going to happen to the y's? Well, they're going to get 2 added to them. So instead of 0, it's going to be 2. So instead of 2, it's going to be 4. Instead of 4, it's going to be 6. Instead of 6, it's going to be 8. Instead of 8, it's going to be 10. All right? All right, let's graph those points, and let's see what's happening. Well, now -2 is 2. It's here. -1 is 4. It's here. -0 is 6. It's here. 1 is 8. And then what happened? Look what happened. All that happened was, I wish I could zoom way in on this. All right, yeah, I can. All right, all that's happening is these points are moving upwards too. Yeah? So it's going to be like this. All right. I set it as a point. What's going to happen to the points? It's going to be x comma y plus 2. What's going to happen to the table? The y coordinates just get added 2 to them. What's going to happen inverbally? This is going to be horizontal or vertical? Vertical because it's affecting the y. A vertical translation up 2. All right. This is everything that you need to write. This is the connection with this. Any questions there? All right, so give me some feedback. Does that make sense? Yes or no?
Yes.
Yeah,
Yes.
makes sense.
All right, let's do another one. Now we're going to do a little bit harder one. We're going to do f of x. Notice what it says, minus whatever c is. C is 2, so it's going to be f of x minus 2. Okay? All right. Can I predict what the points are going to look like? It's happening inside the parentheses. If it's happening inside the parentheses, what is it going to affect? The x or the y?
The x.
The x. And it's going to affect the x the opposite of what it says. So right now it says take the x's and subtract 2. So what am I really going to do?
Add
Add 2.
Right, it's going to be x plus 2, comma what?
Comma y.
Right, it's not changing.
Y.
That's right, it's not changing. Nice job. All right. So I'm going to make these table. I'm going to make this table here, right? So here's x, y. All right. I know that the y's are going to stay the same. So I'm going to take these points. That was my original graph. And I'm going to write them here. Can I predict what the y's are going to look like? Yes. I'm going to take these x's and I'm going to add 2 to them. So -2 becomes 0. -1 becomes 1. 0 becomes 2. 2 becomes, or sorry, yeah. 1 becomes 3, right? And 2 becomes 4, right? Can I predict what that's going to do to the graph? Yes. Let me graph my original equation again, right? -2 is -2. -1 is -4. 0 is, wait, did I, 0? Oh, I messed up. Hold on, let me do it again. I'm graphing this right here, yes? I'm graphing the original again, so all right, so if I graph the original again, it'll look like that, right? All right, can I predict what's going to happen to those points, right? So I've got these points here. Yes, in fact, I should go farther. Can I predict what's going to happen to those points? Yes. It says -2, but I'm actually going to move them forward 2. So I'm going to do my second graph. It's going to move them forward 2. It's going to look like this. All right. I'm sorry, that's crooked. It's really hard for me to draw on here. All right. And then what's happening? They're all just moving forward, too. Yeah? So can I describe this in words? Yes. It's going to translate the graph horizontally right 2. There we go. Any questions there? On a scale from 1 to 10, 10 being you completely understand it, 0 being Gillespie, you suck at this and I don't understand this, where are you on that scale right now?
10.
10.
10.
10.
All right, good. That's better than I thought. Aaron, what about you?
Sorry, I was writing the graph down. What was the question?
Oh, forget it. It's all right. All right, next one. F of x equals, we're going to graph f of x equals x minus 4. So let's graph that first. If I were you guys, when I did my homework, I would graph both, because you're going to have 2 graphs, right? Graph 1 and graph 2. I would graph that on both of them real quick and just be done with it, right? So let's make our table for this. Although we can graph these much quicker without the table, right? Because we know how to, we know to start at the y, and actually we need points anyways. So, oh, since we're doing half, we should make multiples of 2 for x. So we should probably do like -4, -2, 0, 2, and 4. All right. So let's do that. -4, half of -4 is -2 minus 4 is -6. Half of -2 is -1 minus 4 is -5. Half of 0 is 0 minus 4 is -4. Half of 2 is 1 minus 4 is -3. And half of 4 is 2 minus 4 is -2. So let's graph those points. And I'm going to graph it twice on each graph real quick. -2, -4, -6 is here. -2, 5 is here. 0, -4 is here. 2 is -3. And 4 is -2. So my graph looks like this. All right, let's graph it again since we're going to use it twice. -4 is -6. And then it's up 1 over 2, up 1 over 2, up 1 over 2. All right, so there's my graph, right? All right. If you get behind me, you can just watch the video again, so it's not that big of a deal. All right. All right, so let's do. We're now going to do, what does f of x, and look what we're doing this time. It's minusing 4. So what does f of x minusing 4 with the minusing 4 outside the parentheses, right? We're going to do two things. How does it affect the table? How does it affect the points? All right, so let me ask somebody. Let me just call in somebody random. Bailey, you there?
Yes, sir.
All right, Bailey, is it going to affect the x or is it going to affect the y, and why is that true?
It's going to affect the y because it's outside the parentheses.
Good. It's going to affect the y, so the x is going to stay the same. Good job. And what's going to happen to the y, Bailey?
It's gonna translate down 4.
So it's going to take the y coordinate and subtract 4. That's correct. Nice job. Perfect. All right, David. You there? Is David not there? 5, 4, 3, 2, 1. Booted from the class. Alora, are you there?
Yes, I am.
All right. What's going to happen to the points? Can you predict what's going to happen to the points? Right? Look at this table. And can you predict what this table is going to look like for f of x minus 4?
Okay, so -4, x, if x is -4, then y would be -10.
Good.
If I'm just gonna keep listing them, so x -2, y would be -6. If x is 0, y would still be -4. And then if
Hold on. When x is 0, would y still be -4? No, it'd actually be -8. Oh, hold on. I think you made a mistake. Yeah, you did. Yeah, you did. Because look, if x is -5, you're going to subtract 4, so it's going to be at -9. So you're going to the y was and subtract 4. So there's your mistake.
Okay, yeah, I made a mistake.
So what's the next one? 0 is going to be what?
Hold on, I'm trying. Okay, so then 0 would be -8.
Good job. 2
And
would
then
be,
2 would be -7.
and then 4 would be -6. Yeah?
Yes.
All right, good job. Can I predict what's going to happen? Can you mute yourself, please? All right, so what's going to happen? Well, it's just going to take each point and it's going to move it to the right, or sorry, to the left 4. It's going to be here. 1, 2, 3, 4. It's going to be here. 1, 2, 3, 4. It's going to be here. 1, 2, 3, 4. It's going to be here. 1, 2, 3, 4. It's going to be here.
Mr. Gillespie?
Oh, shoot. What did I just, good. Someone catch me. I think you're going to tell me what I just did wrong, Josh. What did I do wrong, Josh?
Yeah. Aren't you supposed to move it down and not to the left?
There you go. Down 4. Sorry. 1, 2. So 1, 2, 3, 4 down, right? 1, 2, 3, 4 down. 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 Did David ever come back into the class? David, when I called you, how come you didn't answer?
I wanted to go print the notes.
How far into the class are we?
My printer wasn't working for some reason.
Okay, I told you guys when you step away from the class, what are you supposed to do? Put it in the chat bar. I have to step away for a second. Otherwise, I'm going to count you absent. I'm going to tell you that that's happening every single day from now on. If I call on you and you don't answer me and there's nothing in the chat bar that says that you need to step away for a second, then you're going to be counted absent. David, does that make sense?
Yes, sir.
All right, so that's what's happening. It's just moving the graph down 4. All right, there's that one. I'm going slow here, guys, but I think you're going to go a lot faster than me, okay? So, all right, next one. Now let's do the harder one. Let's do f of, notice what I said here. Let's go all the way back to the beginning. It's f of x minus whatever c is. So we're going to do f of x minus a -4, right? Which is really saying what, guys? What is that really saying?
F of x plus
Plus
Plus 4. Plus 4, not plus 5. Whoever said that. All right. All right. So let's call somebody random. Garrett, you there?
Yes.
All right, Garrett. What do you think is going to happen to the points? Is it going to affect the x or the y?
It's going to affect the x.
So I know the y is going to stay the same, so I can just put y there. Yeah? What's going to happen to the x?
It is going to be translated to the left 4. So like
Good.
subtract 4.
Beautiful. Now, why you did opposite? Good. He caught it. Okay. It does the opposite of what it says. If it says plus 4, it's -4. So he's right. All right. Good job, Garrett. Thank you. And then let's see, Joaquin, you there?
Yes, sir.
All right. So the y's stay the same. So I'm going to take my original y's, right? These points that I'm circling, and they're going to come straight down, right? -6, -5, -4, -3, -2. What's going to happen to the x coordinates? What are they going to be? This is what this is saying. Take whatever the x was and subtract 4 from it.
Oh. Okay, so if y was -6, x would be 0.
What is -4 minus 4 on your planet?
Oh, okay, -8.
Okay. Second point. -2 would become what?
-2 would become -6.
That's right. 0 would become?
-4.
You get it now. 2 would
And then
become?
-2 and then 0.
And 0. All right. So let's graph those points and let's see what that's going to look like. -8 is going to become -6. Thank you. You can mute your mic now. -8 becomes 1, 2, 3, 4, 5, 6. Right? Now look, it looks like that point right now is happening like this, right? And it actually is, but it also kind of looks like, no, it actually does, huh? It doesn't, I almost made the mistake. It almost looks like it's moving up and down, but it's not. What's happening? It's moving it this way, yeah? Moving it that way, 4. So it's going to take each point, 1, 2, 3, 4, and move it backwards 4. 1, 2, 3, 4. 1, 2, 3, 4, right? So what's happening? It's going to look like this. Yeah, what's happening? Each point is moving to the right, or sorry, to the left 4. All right. So I didn't say this on this first one. I didn't say this on this one. This one, it's going to translate vertically down 4, right? This one's going to translate horizontally left 4. Yeah? All right. That's what I wanted you guys to get today. All right? How to do that. How to move these points. Does that make sense?
Yes, it does.
yes.
Good. I'm sure you're not going to be great at this right now, and I'm totally okay with that. So let me stop recording.